Bolshoy Lyakhovsky Island, or Great Lyakhovsky, is the largest of the Lyakhovsky Islands belonging to the New Siberian Islands archipelago between the Laptev Sea and the East Siberian Sea in northern Russia. It has an area of 4,600 square kilometers and a maximum altitude of 270 meters. The peninsula projecting towards the west of the island is the Kigilyakh Peninsula. Off Bolshoy Lyakhovsky Island's southwestern cape lies a small islet called Ostrov Khopto-Terer. The Lyakhovsky Islands are named in honor of Ivan Lyakov, who explored them in 1773. Geology. Bolshoy Lyakhovsky Island consists of highly folded and faulted Precambrian metamorphic rocks and turbidites, Mesozoic turbidites and igneous rocks, and Cenozoic sediments. Exposed in southeastern part of this island, the older Precambrian, early Proterozoic, metamorphic rocks consist of schists and amphibolites. Small exposures of late Proterozoic schistose, quartzose sandstones and phyllite, sericite quartz schist also occur in the southeastern part of Bolshoy Lyakhovsky Island. The bulk of this island consists of late Jurassic to early Cretaceous turbidites composed of interbedded fine-grained sandstones, thinly bedded siltstones, and argillites. The Precambrian and late Jurassic to early Cretaceous rocks are intruded by late Cretaceous granites and granodiorites. A blanket of unconsolidated Cenozoic sediments blankets most of Bolshoy Lyakhovsky Island. These sediments include Paleocene to Eocene alluvial, and deltaic gravels, sands, clays, and coals, and Oligocene to Miocene alluvial, lacustrine, deltaic, and nearshore marine sands and clays that contain beds and lenses of gravel. Overlying these sediments are Pliocene to Pleistocene alluvial, and nearshore marine sands, silts, and clays that contain occasional gravel layers. The nearshore marine sediments contain the shells of marine mollusks and pieces of lignitized wood. Thick permafrost characterized by massive ice wedges has developed in these sediments. Contrary to the interpretations of Baron von Toll and earlier geologists, glacial tills and related sediments are completely absent within Bolshoy Lyakhovsky Island. Quaternary Geology. The southern sea cliffs of Bolshoy Lyakhovsky Island, which were first studied by Baron von Toll, expose a complex sequence of fossiliferous late and middle Pleistocene floodplain, aeolian lake, and solifluction sediments cemented by permafrost. In the 1990s and 2000s, a Russian-German multidisciplinary team, which included the Alfred Wegener Institute for Polar and Marine Research and Permafrost Institute, Russian Academy of Sciences, studied the cryolithology, geochronology, ground ice geochemistry, paleobotany, paleontology, sedimentology, and stratigraphy of these sediments. The age of these sediments were studied in great detail using radiocarbon dating of bones, ivory, and plant remains, optically stimulated luminescence dating of bone-bearing sediments, and uranium-thorium dating of associated peat. The oldest sediments exposed in the southern sea cliffs of Bolshoy Lyakhovsky Island consists of a layer of rocky, yellowish to greenish-colored sediment. This layer is a thick Paleogene weathering crust that has developed within Permian sandstone. This paleosol has been largely modified by periglacial processes and development of ice wedges periodically during the Pleistocene. These deeply weathered sediments are unfossiliferous and characterized by the presence of weathering products like kaolinite and montmorillonite. Salian sediments uncomfortably overlay this paleosol. Pol. The oldest known Pleistocene sediments exposed in the southern sea cliffs of Bolshoy Lyakhovsky Island consist of Salian sediments, which accumulated between 200,000 and 120,000 years ago. The lower part of these sediments consist of ice-rich, silty and silty-sandy sediments that accumulated as an Salian ice complex between 200,000 and 170,000 years ago. They contain pebbles, peat inclusions, and peat horizons. The presence of ice belts, reticulated ice interlayers, and wide, round-shouldered ice wedges indicate that permafrost formed in these sediments as they accumulated. The lower part of this unit contains the pollen of sparse grass sedge vegetation, which reflects a stadial environment. The upper part of this ice-rich unit contains pollen associated with dense grass-dominated tundra, which is indicative of interstadial environments. The upper part of the Salian sediments, which lie uncomfortably on the eroded surface of the lower Salian ice complex deposits, consists of well-sorted fine-grained sand that contains pollen characteristic of sparse grass sedge-dominated interstadial vegetation and less ground ice. These loess-like sediments accumulated within floodplains and lakes, as they accumulated between 170,000 and 120,000 years ago. Ice wedge polygons formed in these sediments as the result of extremely cold and dry conditions. Elsewhere along the coast of Bolshoy Lyakhovsky Island, the sea cliffs expose pre-Eemian floodplain and lake sediments at the base. Eemian lake sediments fill depressions, i.e., ice wedge karsts and thermokarst lakes, which develop by the surficial thawing during Eemian interglacial climates of Salian ice wedges and other permafrost. In some locations, the Eemian lake deposits are thicker and laterally continuous enough to form a complete blanket overlying older sediments. The Eemian sediments contain fossils indicative of an interglacial environment. At many localities along the sea cliffs, typically over 10 meters of early Vicalian lacustrine and loess-like floodplain deposits overlay the Eemian and pre-Eemian sediments. These sediments consist of fine-grained, well-sorted sands with rare grass and sedge pollen. They contain ice wedge polygon systems that formed during the early Vicalian stadial about 100,000 to 50,000 years ago, as the result of extremely cold and dry conditions, typically 15 to 20 meters of middle Vicalian ice complex deposits, which consist largely of aeolian sediments that accumulated 50,000 to 28,000 years ago, overlay the early Vicalian sediments. These sediments contain pollen typical of the mammoth tundra steppe environments and large ice wedge polygon systems. These sediments accumulated within a swampy, poorly drained habitat, which existed under an extremely cold continental climate. A zone of peaty deposits within this ice complex accumulated during a middle Vicalian interstadial about 40,000 to 30,000 years ago. The middle Vicalian deposits underlie the upland surfaces of this part of Bolshoy Lyakhovsky Island. Within the southern sea cliffs of Bolshoy Lyakhovsky Island, late Vicalian sediments of the last glacial maximum have not been found. The ice complex deposits associated with this period of time appear have been eroded and covered by Holocene deposits, where thermokarst depressions have formed by melting of the permafrost. They are filled by Holocene solifluction and lake sediments. These depressions formed as the result of the thawing of ice wedges and other permafrost during the late Pleistocene-Holocene transition about 12,000 to 10,000 years ago. The lacustrine sediments filling these depressions contain a record of the Aleroid warming, Younger Dryas cooling, and other climatic events. Holocene fluvial and solifluction deposits underlie valleys of streams cut into underlying Pleistocene sediments. Solifluction deposits which were created by melting of the underlying permafrost near the surface of the uplands. New ice wedge polygon systems later formed in these sediments during the late Holocene as result of pronounced climatic cooling, which only recently has reversed in the last couple of hundred years, because of the formation of permafrost in these sediments and the depositional environments. Prehistoric bone, shell, and plant material are well preserved and abundant. As noted above, later researchers found that the bone and wood-bearing sediments described by Baron von Toll consist of both glacial, Salian and Vicalian and interglacial, Eemian and Holocene, sediments. For example, Baron von Toll's alder tree was found in Eemian sediments, which are about 114 to 130,000 years old. The vertebrate fossils occur in sediments that range in age from 114,000 to less than 8,000 BP. Baron Eduard von Toll was among the first to report in detail about the abundance of Pleistocene fossils found within Bolshoy Lyakhovsky Island, under a peak composed of water mosses covering what he described as perpetual ice, now known to be permafrost. Baron von Toll found fragments of willow and the bones of post-Neogene mammals, like the shoulder bone of a saber-toothed tiger. He also reported having found in a frozen, sandy clay layer and lying on its side, a complete tree of Alnus fruticosa 15 to 20 feet in length, including roots, with leaves and cones adhering. Unfortunately, his reports have been frequently either misrepresented or badly garbled by popular accounts of his findings. For example, various authors, i.e. Dr. Digby and Dr. Kropotkin, misreport this tree as being 90 feet high. Other publications, i.e. Fingerprints of the Gods and Earth's Shifting Crust, not only incorrectly state that this alder tree is 90 feet high, but they also repeat fictional claims from unreliable sources that this tree was either a fruit tree or plum tree, and had green leaves and green fruit still attached. Lacking modern radiocarbon dating techniques, Baron von Toll assigned this tree and other fossils to single mammoth period, as discussed above. More recent geologic research and radiometric dating of these fossils and the sediment containing them has found that they are from different layers of middle to late Pleistocene glacial and interglacial sediments. Climate. The Cape Shalarovo Meteorological Station, which lies on the southeast coast of Bolshoy Lyakhovsky Island, at 73 degrees 11 N 143 degrees 56 E, provides climatic data for this island. The mean precipitation is 184 mm per year as calculated for a 7-year period between April 1994 and September 2000 as calculated from National Oceanic and Atmospheric Administration data. The heaviest precipitation, about 2/3 of the yearly total, occurs between June and September, as calculated from the same data for the same period of time. The mean temperature at Cape Shalarovo is -13.6 degrees Celsius. January is the coldest month with a mean temperature of -31.0 degrees Celsius, and August is the warmest month with a mean temperature of 2.4 degrees Celsius. Mean daily temperatures range as low as -40.5 degrees Celsius and as high as 9.4 degrees Celsius. Vegetation. The vegetation of Bolshoy Lyakhovsky Island is a mixture of rush, grass, forb, cryptogam tundra, cryptogam herbacean, and sedge, grass, moss wetland. The rush, grass, forb, cryptogam tundra covers the bulk of Bolshoy Lyakhovsky Island. It consists mostly of very low-growing grasses, rushes, forbs, mosses, lichens, and liverworts. These plants typically cover about 40 to 80% of the surface of the ground. The soils are typically moist, fine-grained, and often hummocky. The cryptogam herbacean consists of dry to wet barren landscapes with scattered herbs, lichens, mosses, and liverworts. Sedges, dwarf shrubs, and peatmires are normally absent. These plants form a sparse and low-growing plant cover that often occurs as dark streaks on the otherwise barren lands, composed largely of bryophytes and cryptogamic crusts. Sedge, grass, moss wetlands, which occur on the northwest and southeast ends of Bolshoy Lyakhovsky Island, consist of wetland complexes dominated by sedges, grasses, and mosses. These wetlands occupy low, perennially wet parts of the landscape.